it would be amazing to be able to create every single year a vaccine that is, expected to be protective, but this is unfortunately not possible in a pig industry reality. So we are trying to adapt the human approach to a more, easy to use and realistic approach in the agricultural reality.
Welcome to the Swine Health Blackbelt Podcast, the latest swine health research digested for you. My name is Dr. Clayton Johnson, and I'm the host of the podcast. Joining me in our podcast studios for this week's edition, returning, I should say, for this week's edition, is Dr. Elisa Crisci. Dr. Crisci is an assistant professor of virology at North Carolina State University. And Dr. Crisci, I know you are a proud veteran alumni of the podcast here, but just in case maybe folks haven't heard some of our previous episodes, why don't you start out with an introduction for the audience?
Yeah, thank you. Yes, I'm Elisa Crisci. I've been at North Carolina State University Veterinary College about 6 years now. I'm mainly a researcher that works on pig virology and immunology, and in particular focusing on specific pig diseases like porcine reproductive and respiratory syndrome virus. And that's why the topic for today is referred to PRRS. So that's what we are working on in the last 6 years.
I am so excited, Elisa, to get started on this one. PRRS is always a hot topic in our industry. If you're not dealing with PRRS right now, fantastic, good for you. But for most producers, it's on the top of their mind. For most veterinarians, it's one of the biggest challenges they deal with. You're working, collaborating with Dr. Gustavo Machado, I understand.
Yes.
A big project, Predict and Protect. Talk to us a little bit about what that means. Predict and protect PRRS. What are we talking about?
Yes. So thank you. Yeah, this is a huge interdisciplinary proposal that we submitted to USDA, NIFA ideas that covers this kind of interdisciplinary studies where we have multiple disciplines and people working on it. So it's me, Dr. Gustavo Machado, but there's all the other people from NC State, in particular Dr. Ferreira, Dr. Almond, and of course Dr. Kaiser, that he was also here at NC State, and now he moved back to his alma mater in Vienna, but he's still working with us on the project. The project has this acronym that we call PRRRS, because we have a portion of prediction of forecasting technology. So Dr. Machado can predict of the virus throughout an area in different farms, and he's trying to add in the modeling also the capacity to predict the movement of the specific strain throughout the different farm and area. So he, of course, works on a lot of variable factors that can influence the movement of the virus. And if you want more detail on epidemiology, he's the person to contact for this information. My portion is mainly related to what we call a prediction vaccine system, that is an in vitro system that allows us to give kind of prediction on the vaccine, of the commercial vaccine that is currently available. We are testing different of them, and we can tell which vaccine will give a better protection towards a specific strain that is circulating in the field. This is a prediction that is based on an in vitro system, but you need to create an immunobiobank to work with this prediction system. So we have practically vaccinated several pigs with a different vaccine. We have collected their peripheral blood and serum, and in particular PBMC, so the cells that are actually in the blood. And we use those cells to perform an in vitro assay that is in particular is a interferon gamma production in vitro assay, and that will give us some immunoresponses based in vitro on how those cells will perform towards a specific strain. We know those are correlate to protection, so we can estimate based on those assays if that vaccine will be the best shot for the coverage in terms of, towards specific strain. We also use seroneutralization, combine the cellular immunity with the humoral immunity to give a prediction on a vaccine efficacy towards a specific strain.
Dr. Crisci, this sounds a lot like the human flu vaccination program. You have to predict what strains will be the most relevant in the future. And then you also need to try to create a vaccine program that gives you the best chance at protecting against those strains. Is that a fair analogy?
Yeah, exactly. It's very similar. The only different that, of course, in an agricultural context, we cannot produce every single year a new vaccine that has the strain that are circulating. So we are trying to instead use the tool we have available, so the vaccines that are actually currently commercialized in US, and test those towards the strain that is circulating. It would be amazing to be able to create every single year a vaccine that is, expected to be protective, but this is unfortunately not possible in a pig industry reality. So we are trying to adapt the human approach to a more, easy to use and realistic approach in the agricultural reality.
Well, I'm sure we would want to ideally do in vitro research, right? We would want to have pigs be the experimental unit and challenge pigs with the specific wild type strains we're concerned of. But I have to imagine that the cost of doing that would be so resource intensive that it's probably not practical for every strain of concern.
Exactly. It's not really practical, and if each challenge trial will take a time, you will need to evaluate the data, so the responses won't be actually efficient in timely manner. And the in vitro system will help us, speed up that process. Of course, it cannot be an animal that is challenged with a virus, but can help the prediction and have some tools that will help, for example, giving a recommendation to farmers or to pig producer, if you have that circulating strain that we know is moving around, because Dr. Machado can predict that movement from our biobank, we know that for that strain, the best approach, or the best shot you have to try to mitigate or to reduce the PRRS, outbreak, is that specific vaccine.
You mentioned serum neutralizing antibodies, and I assume that's a pretty important part of your prediction tool, is trying to quantify those. What are some of the other diagnostic assays or in vitro tests that you utilize as part of the vaccine cross-protection prediction analysis?
Yeah, so seroneutralizing antibody, people are very familiar with that. We recently published actually a paper where we talk about correlates of protection, and we found out that seroneutralizing antibodies are good predictors for protection. We also have a cellular assay that we call, because we use, as I said, these cells that have memory towards a specific vaccine, and we try to re-stimulate them with a wild type strain and see how much they respond towards that new strain by producing interferon gamma. And that's also kind of, cellular immunity approach that will tell you how good are your memory cells to respond to when they encounter a new strain, and how effective they are in mounting a good immune response towards that one.
For your assays you're trying to do, I presume you have to grow the wild type strain to be able to do those assays, or is there anything you can do with the sequence alone for those strains that don't grow very well?
Well, we need to have the isolate to perform those tests, because there won't be a prediction, in particular with cellular immunity, if we don't have an isolated virus. But because we are testing a range of strains, so we can, for example, say that strain, that vaccine has worked best towards that strain. We have the annotation of that strain. And if, for example, if you can run a homology with another strain, that might be helpful, and that will be, a potential similarity. And so you can say maybe that vaccine will also work towards the other strain. So there is some computational approach you can run afterwards, but you need to have like the initial panel of strain that you're using to compare and have some data, real data that is telling that vaccine works best towards a specific strain that maybe people know has a 174 or 134 or other type that are generally defined by those RFLP sequence.
It's probably appropriate for us to put a huge disclaimer on all this, right? That anytime we start talking about PRRS strains, it gets very complicated and easy to talk past each other. And what I mean by that is, like, when I say 174, my version of 174 could actually be wildly different than your version of 174. So really important for producers that if you're going to use this information, take the time to understand what you're talking about, because it is easy with PRRS to get to not apples to apples comparisons when we may assume they are apples to apples.
Exactly. I mean, there is difference between what we call 174 between geographic areas. This virus has a huge recombination capacity. I have our time to use this kind of definition for strains. But I understand that producers got used to this type of identification of per strain. So as long as we are able to communicate, clearly which type of strain we have tested and what type of outcome we got, I hope we will be able to, educate producers also on those kind of thing and the approach that we are using.
Salmonella presents significant challenges to pig health and performance and poses food safety risks to humans. As the first and only vaccine offering live attenuated strains of both Salmonella cholerae and Typhimurium, Enterosol Salmonella TC from Boehringer Ingelheim protects pigs against both serotypes with a single oral dose. Talk to your Boehringer Ingelheim representative to learn more.
I really appreciate, Elisa, you coming on the podcast and sharing this information. You've been a great guest before, and it's tremendous work you guys are attempting to do. It is certainly a huge project you're working on. PRRS prediction and protection are things that we've tried to make better for a long, long time, and I applaud you for continuing that effort.
Thank you. Yeah, we are trying. We know he's ambitious. We are trying to do our best to give answers. And we know we might not find the final answer. So this is the world of PRRS.
Well, and where we can make incremental improvements, right, where we're not able to test every wild type strain in pigs, classic challenge model type data, right? Don't let best be the enemy of better. If we can develop some tools that help to bridge that gap, fantastic.
Yeah, we are trying to do that.
Well, thank you very much, Dr. Crisci, for coming on the show.
Thank you very much for having me today and allow me to talk about this great project we are currently working on.
Well, we can only do it because of our audience. And thank you to the audience for tuning in. Appreciate you listening to the Swine Health Blackbelt Podcast. Please check us out at swinehealthblackbelt.com. And don't forget to subscribe to the podcast so you don't miss every episode that we put out every week. For Dr. Elisa Crisci, I'm Dr. Clayton Johnson. Thank you very much for joining us, and have a great rest of your week.
Thank you, you too. It was a pleasure.
Hey, everybody. We're always searching for the latest and greatest research to share each week. If you have a swine health-related research trial and would like to come on the show and talk about it, share it with us, please feel free to email the research to hello@wisenetics.com. That's HELLO@WISENETIX.com.